Welcome to CIE Math Solutions. In this video, we will discuss how to find the probability of non-mutually exclusive events. Welcome to another video of CIE Math Solutions. In this video, we will recall the main differences between mutually exclusive events and non-mutually exclusive events. We will also discuss the probability rule as well as the examples of finding the probability of non-mutually exclusive events. Before that, let us recall the differences between mutually exclusive events and non-mutually exclusive events. Also, if you would like to watch the previous video showing examples of how to find the probability of mutually exclusive events, you may click down on the description below, or you may click on the link above this video. In our previous video, we have already discussed the main differences between mutually exclusive and non-mutually exclusive. So for mutually exclusive, they are disjoint. That means no common elements. For non-mutually exclusive events, they are joint or they have common elements. If we will illustrate them in a Venn diagram, for mutually exclusive, we would see two separate circles denoting event A and B. They are not intersecting at all, so the intersection of A and B is a null set, meaning there is no intersection. So that will go with the probability that probability of A intersection B is equal to 0. For non-mutually exclusive events, you could see that they intersect in the middle. They have a common element, so that means A intersection B is not a null set. The same goes that the probability of A intersection B is not equal to 0. Before we proceed with non-mutually exclusive events, let's take a look first at this scenario. First, if we have an experiment of rolling a regular fair 6-sided die, we will have the results 1, 2, 3, 4, 5, and 6. If we want the event of getting an even number, then that will be having the probability of even, that is 2, 4, 6, we have 3 out of 6. How about if we are finding the probability of a number less than 5? So probability of a number less than 5. There are 4 of them, 1, 2, 3, 4. So we have 4 out of 6. If we would like to find the probability then of an even or a number less than 5, probability of an even or a number less than 5, using the probability rule that we have discussed before, we simply add them. We have 3 over 6, the probability of even, plus 4 over 6, the probability of a number less than 5. If we add them, this is equal to 7 over 6. However, looking at the probability, 7 over 6. 7 over 6 is definitely more than 1. Probability rule number 1 is that the probability must be from 0 until 1 only. None of it must go beyond 1. That means this probability is not correct then. We should not get a probability that's more than 1. What is the reason why this is not correct? If we take a look at these results, probability of even and probability of number less than 5, we could see there that both of them contains 2 and both of them contains 4. They have the common elements. This means that these events are non-mutually exclusive events. Non-mutually exclusive. So that means if they are non-mutually exclusive events, then we cannot use the probability rule that you simply add the probability of the first event plus the probability of the second event. The question now is, how can we find the probability of non-mutually exclusive events then? The probability of non-mutually exclusive events is equal to the sum of the probabilities of the individual events minus the probability of the common elements. In other words, probability of A or B is equal to probability of A plus probability of B minus probability of A intersection B. You simply add the individual probabilities of A and B, and then you subtract the probability of the common elements between them, since they are non-mutually exclusive. If we take a look at the Venn diagram, we would see again that there are two circles that are connected to each other. So in this case, the probability of A plus probability of B, and we need to subtract the probability of the common elements between them so that the total will not go beyond 1. Now to make it clearer, let's have an example. Example 1. A fair 6-sided die is rolled. Find the probability that it shows, first, an even number or number less than 5. We know that for the die there are 6 results. If we list down for the event of getting an even number, the output or the results are 2, 4, and 6. Writing down the probability of even is equal to, there are 3 of them out of the 6 results. How about the event of getting a number less than 5? That will be 1, 2, 3, and 4. So probability of a number less than 5, let me just write it down, less than 5, is equal to 4 out of 6. However, since they are non-mutually exclusive events, we need to take note the common elements between them. In this case, the common elements are 2 and 4. So then, it means that the probability of even and less than 5 would be 2 and 4. That means 2 out of 6. If we are finding then the probability of even or a number less than 5, we will then add the probability of an even, which is 3 over 6, plus the probability of a number less than 5, which is 4 over 6, but we need to subtract the common elements between them. We have 2 over 6. This will give us 7 minus 2, which is 5 over 6. The probability then of getting an even number or a number less than 5 will be 5 over 6. Second item, an odd number or a prime number. So again, let's list down the elements of each of the events. Event that is getting an odd number, we have 1, 3, and 5. Writing down the probability of each, the probability of getting an odd number is equal to 3 over 6. How about the event of getting a prime number? We have 2, 3, and 5. Writing the probability of prime is equal to 3 out of 6. Again, take note if these events are mutually exclusive or not. If we take a look at the results, there is a common element. We have then the common elements, there are 2. We have 3 and 5. So the probability then of getting odd and prime at the same time is equal to 2 over 6. So the probability then of getting an odd or prime will be the probability of odd, which is 3 over 6, plus the probability of prime, which is 3 over 6, minus the probability of odd and prime at the same time. There are 2 of them, so 2 over 6. We will then have the probability to be 6 minus 2, that is 4 over 6, or 2 over 3. The third item, a number divisible by 2, or multiple of 3. The first event again is a number divisible by 2. This is the other way of saying that it is an even number actually. So what are those even numbers or divisible by 2? We have 2, 4, and 6. If you write down the probabilities, probability of even or divisible by 2, we have 3 over 6. And the event of getting a multiple of 3, there are only 2. So probability of multiple of 3, that is 2 out of 6. Since there are only 2 of them, 3 and 6 only. Now again, let's check. Is there any common element between them? Yes, there is. The common element is 6. So the probability of getting an even at the same time, a multiple of 3, is 1 out of 6. So if we are finding then the probability of an even or a multiple of 3, then we then have 3 over 6, which is the probability of even, plus 2 over 6, which is the probability of multiple of 3, minus 1 over 6, which is the common between them, an even number at the same time, multiple of 3. This will then be 3 plus 2 is 5 minus 1, that is 4 over 6 or 2 over 3. If you have questions about example 1, or if you see any corrections or errors, please write them down on the comment section below. Let's go to example 2. Example 2 says, a card is drawn at random from a standard deck of cards. Find the probability that the card drawn is, first, a red card or an ace card. Looking again at the deck of cards, there are 52 cards all in all. The red card are those cards that are on the lower half. So all of these are red cards. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. There are 26 of them. So if you write down the probability of a red card is equal to 26 over 52. Next is the event of getting an ace card. So ace cards are this, and this. There are 4 of them. So probability of an ace card is equal to 4 over 52. But how about the probability of getting a red and ace at the same time? How many are they? Looking at them, this will be the common between them and the common between them. There are 2 of them. So we have 2 out of 52. If we would like now to find the probability of a red card or an ace, that will then be 26 over 52 plus 4 over 52 minus the common between them, which is 2 over 52, which will give us an answer of 28 over 52. Simplifying them further, 28 over 52 is equal to 7 over 13. Again, red card and ace card are non-mutually exclusive events because they have a common element. There is an ace of hearts, which is also red, and an ace of a diamond, which is also a red card. Going to double I. Double I, a diamond card or an even number. Again, let's take a look at the deck of cards. The diamond are all here on the lowest part of the deck of cards. So this contains 13 of them. So probability of getting a diamond is 13 over 52. The next event is the event of getting an even number card. So probability of even numbered card. Now let me encircle all of them. So 1 would be definitely all of this. 2, 4, all of them. 6, all of them. 8 and 10. So we have, there you go. There are 4 number 2, 4 4s, 4 6, 4 8s, and 4 10s. So all in all, there will be 20 out of 52. If we would like to find now the common between them, probability that it's a diamond and even at the same time, if we take a look at the intersections, there will be 2 of diamonds 4 of diamonds, 6 of diamonds, 8 of diamonds, and 10 of diamonds. There are 5 common elements between them. So this will then be 5 out of 52. So in here, if we would like to find now the probability of a diamond or even, then we will then have 13 over 52 plus 20 over 52 minus the common, which is 5 over 52. So if we will add or simplify this now, we have 33 minus 5, that will be 28 over 52 or 7 over 13. So the probability then of getting a diamond card or an even number is 28 over 52 or 7 over 13. Next is the probability of getting a black card or a face card. So if we take a look at the deck of cards, there are 2 types of black cards. We have the clubs and the spade. There are 26 of them. So the probability then of getting a black card is equal to 26 over 52. The next event is the probability of getting a face card. Probability of a face card. So again, the face cards are all of these. There are 12 of them. So the probability of getting a face card is 12 over 52. Now, is there any common element between them? Probability that it's black and face at the same time? There are. Let us encircle them. We have Jack, Queen, King. We have another Jack, Queen, King, spades and clubs. So we have then 6 over 52. They are face cards at the same time, they are also black cards. So if we are finding the probability of a black or a face card, since they are non-mutually exclusive, we will add them. 26 over 52 plus 12 over 52, but we need to subtract the common between them. Adding these probabilities, we have 32 over 52, or in simplest form, 8 over 13. The probability then of getting a black card or a face card is equal to 32 over 52 or 8 over 13. Example 3. The numbers 1 to 20 are written on separate flashcards. If a card is chosen at random, find the probability that the number on it is first an even number or a prime number. Again, let's show the flashcards 1 to 20. The probability of getting an even, the even numbers here are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So the probability of getting an even number is equal to 10 out of 20. The next event is getting a prime number. So if we will be getting a prime number, let's encircle them. The first prime is 2, the second prime is 3, then we have 5, then we have 7, we have 11, we have 13, we have 17, and we have 19. So if we will find the probability of getting a prime number, the probability then of getting a prime number is 8 over 20. Now, is there a case or the possibility of getting an even at the same time prime? So even and prime at the same time. So we have the intersection there. We have a 2. So that means this will be 1 over 20. The probability then of getting an even or prime will be the probability that it's even, that is 10 over 20, plus the probability that it's prime, that is 8 over 20, minus the probability that it's both even and prime, so 1 over 20. That will give us the overall probability of 17 out of 20. The probability then of getting an even or a prime is 17 over 20. The second item, a perfect square or an odd number. So from these numbers that we have, a perfect square again is a number that is the result of multiplying a number to itself. So for example, 1 times 1, 1 is a perfect square. 2 times 2, 4 is a perfect square. 3 times 3, 9 is a perfect square. 4 times 4, 16 is a perfect square. No more, because the next will be 5 times 5, which is 25. It's beyond the numbers already. The probability then of getting a perfect square is equal to 4 out of 20. Next would be the event of getting an odd number. So let's encircle those odd numbers. We have 1, we have 3, 5, 7, 9, 11, 13, 15, 17, and 19. So if you will write down the probability of odd number, that is 10 out of 20. Now how about the probability that is a perfect and odd at the same time? If you take a look at the encircled numbers, there are 2 encircled twice, 1 and 9. So the probability of getting a perfect at the same time an odd number is 2 over 20. So if you are now finding the probability of a perfect square or an odd number, that is 4 over 20 plus 10 over 20 minus the common, which is 2 over 20. The resulting probability then is equal to 12 over 20. If we will simplify this will be 3 over 5. The probability then of getting a perfect square or odd is 12 over 20 or 3 over 5. Next, a number divisible by 3 or a number multiple of 4. Let's encircle again the numbers that are divisible by 3. Of course, they are the multiples of 3 also. So 3, 6, 9, 12, 15, 18. And also the numbers that are multiple of 4. Multiple of 4 are 4, 8, 12, 16, and 20. Now let's write down the probability of each. Probability that it is divisible by 3. So the probability that it's divisible by 3, those are the blue ones. We have 6 out of 20. The probability that it is a multiple of 4, those are the orange ones. We have 5 out of 20. The probability that is divisible by 3 and multiple of 4 at the same time, multiple of 4 at the same time is 1 out of 20. That is only 12. So 12 is a multiple of 4 at the same time divisible by 3. So the probability then of a number that is divisible by 3 or a multiple of 4 will then be 6 over 20 plus 5 over 20 minus the common, which is 1 over 20. This will give us 10 out of 20 or 1 over 2. The probability then of a number that is divisible by 3 or a multiple of 4 is 10 over 20 or 1 over 2. If you have questions about these items that we have discussed or clarifications, or if you have seen any errors on the calculations, please write them down on the comment section below. I will soon respond to your comments accordingly. For your homework, a 2 fair 6-sided die is rolled. Find the probability that there is at least one head or at most one tail. B. Both numbers are even or the sum is less than 10. C. Both are prime numbers or the product of the numbers is even. For this homework, you may try to answer them first by your own, And if you would like to verify your answers, you may post them and write them in the comment section below. I will respond to your answers, verifying if they are correct or not. If you are interested to watch more math tutorial videos, you may check the link on the description below or on the link above this video. If you are also interested in watching math shorts, which are 60 seconds long or 1 minute long, you may click also in the description below or click on the link above in this video. You may also visit our blog at www.ciemathsolutions.blogspot.com. From there, you will see free downloadable materials for IGCSE Maths, Pure Maths, Statistics, Additional Maths, and for your own exam preparations. Thank you for watching this video. For more videos on math proofs and derivations, math tutorial videos, solve items from international exams, math tricks and puzzles, math resources, and more, please don't forget to like, subscribe, and share. Thank you very much for your continued support to CIE Math Solutions.